All right. Good morning, everyone. Today is Thursday, October the 21st. We are on day 3 of Hyperbolas. Here we have the bell work. All right. People in chat are putting their answers. So they get y plus 5 squared over 16 minus x minus 3 squared over 25. I'm seeing a lot of that. So that looks pretty good. I think that's, it looks like someone got a different answer. We got a y minus 3 instead of a y plus 5. All right. Oh, you flipped the coordinates. Okay. Yep, there you go. Yeah, it looks like all of you in chat got it right. And if you didn't, you realize what you did wrong, that one person. All right, and double check because you were supposed to fill in these things too. So you need to put the center, the A, your B value, your C value, your two vertices, your two foci, and obviously the actual equation. So who got this right? Good. And again, I said this off the recording, but for those of you who did raise my grade and submitted that, I sent out an email with a Google form link to select your test. I sent it out like 4 times yesterday and once this morning. And apparently it is going to your LC, but it is not going to you, the student. So hopefully your LC talked to you about it, told you about it, and maybe gave you the link, because apparently student email is not working when I send it. I don't know why. But your LC should have gotten it probably 5 times from me. So hopefully they're annoyed enough to show you the email. All right, day 3, general form of a hyperbola. We'll be going from general to standard and standard to general. Make sure you get your paper, pen, pencil, calculator. Just gonna breeze through this. This again is just like a copy paste from the previous 2 days. Nothing new, just the equations of horizontal and vertical. Horizontal equations, vertical equations. Another diagram showing the different parts labeled on the graph, A, B, and C, foci, your center, your vertices. All right, first example. So going from general to standard. This should look similar to, well, ellipses. If I didn't tell you this equation was that of a hyperbola, how would you know? How would you know this equation is a hyperbola and not an ellipse or a circle? Yeah, it's that negative y squared. Yeah, you definitely don't need to convert it to standard to know. So all of you should be able to look at an equation in general form and know relatively quickly if it's a circle, an ellipse, hyperbola, or a parabola, which we haven't started yet. We're doing parabola starting tomorrow. So the giveaway, whenever you look at an equation in general form, you look at the x squared and y squared. If one of them is negative, 100% it's a hyperbola. That's how you know. That negative gives it away. Again, x squared and y squared, we have both of them. One of them is negative. It is a hyperbola. That's how you know. That is important to know. Because on your test, your quizzes, your final, The problem may not tell you. It just may say convert this conic from general to standard, and you need to know. What if what if this was a plus sign? So same equation, but this would be a plus sign. What conic would it be? An ellipse. Why would it be an ellipse and not a circle? Because we have coefficients in front of the x squared other than 1. Yes, that is correct. So if that was a plus sign and one of your coefficients, or both of them, are any number other than a 1, it is an ellipse. Now, so if that was a plus sign, and because that's a 4 in front of the x squared, that would be an ellipse. What if it was a plus sign and it was just x squared and y squared? What conic would that be? That would definitely be a circle. So make sure you know the characteristics: circle versus ellipse versus hyperbola, and identifying what it is in general form, and also be able to look at standard form and know what it is, which I think is a little easier. So good question. What if both of them were negative? That is a possibility. So if both the x squared and the y squared are negative, it is not in general form. You would actually have to move everything to the other side of the equal sign to make them both positive. You shouldn't run into that. I don't think they do. They trick you like that by making both of them negative. Or you could just multiply everything by -1 to flip all the signs to make them both positive. So then it would either be a circle or it would be an ellipse. But good question. But yes, it would still be a conic. They just wouldn't be in the right form. But I don't think they're going to trick you, like I said. Okay, so general to standard. So think about ellipses, because it's basically the same thing. What do we do first? So yeah, we move the constant to the other side, and we can reorder. Yeah. Also, I want to point out, so hyperbolas, one of them is negative. When you reorder them, you want to have the grouping of the one that is positive first. Now, because x squared is positive, you're going to list the x squared stuff or the x stuff first, then your y stuff, and then equals your constant, which I'm going to show you underneath this blue box. So if you notice, see my x squared is positive, so the x stuff is grouped first, followed by my y stuff. Now, if that x squared was negative and this was positive, then I would have my y stuff first, then minus my x squared minus or whatever plus the x equals my constant. So does that make sense? Okay. All right, what's next? Yeah, we greatest common factor, the 4 from the x. Good job. We also GCF the negative from the y stuff. Very good. Very good. Yeah, it's easy to look over this, but we do have to factor out a negative or a -1. Same thing, right? So we pulled out the 4, and to verify, 4 times x squared is 4x squared. 4 times 16 is 64x. And then leave some space because we're going to fill a number in here. And then for the y stuff, do not forget this. This is important. Remember, we are grouping, and we have to factor out this negative. And I actually meant to ask you what are the terms in here, but oh well, I forgot. I was going to see if any of you made the mistake of forgetting to flip the sign of that 20. And to check, negative times positive is negative y squared. Negative times positive is negative 20y. It's a really quick check to make sure that it multiplies out correctly. Because forgetting to flip this negative 20y to a positive y, that is a common mistake. You all will do this and you'll show negative, you'll show parentheses, but then you'll put y squared, then you'll just carry this down because I don't know. I don't know why you do it. It just happens. Okay, what's next? Complete the square. Yeah. So Isabella says that we're going to put 64 here and we're going to put 100 here. All of you agree with that? Yeah, that sounds right. And that's because we take the middle term, 16, and we divide by 2. And then we square it, and that's how we get 64. And then I'll go ahead and do the other one too. 20 divided by 2 squared, we get 100. But what are we forgetting? Yeah, we need to add. But what are we adding to the other side? Are we going to add 64 to this side? What number are we adding to the other side? Yeah, whatever 64 times 4 is, which is 256. Yeah, because 4 times 64 is 256, just like it was an ellipse. And then what else are we adding? Are we adding 100 to both sides? No, we're not quite adding 100. We are actually subtracting 100, which a lot of you put in chat. Because remember, and I did put the 1 there to show this, but -1 times 100 is -100. So we are actually subtracting 100 both sides, not actually adding it. So that's why it is a -100. All right, is that clear on why it's -100 and not +100? Okay. That's also a common mistake. People will forget about this negative, that it's negative whatever number is here times this number is what you're actually add to both sides. So we're adding -100 to both sides. All right, next, we're going to combine this stuff together, whatever this plus this minus that is, to get that number. And what are we doing to these trinomials? Yeah, we're going to factor them. What does the x trinomial become? Yeah, the x plus 8 quantity squared. And we know that because we can take it directly from here. So this is going to factor to become x. In this case, this is a positive 8, so we just put a plus 8 here. But remember just our factoring rules. 8 plus 8 is 16, and 8 times 8 is 64. So another way to check. And then what's the trinomial for the y stuff? Y plus 10 quantities squared? That sounds right. All right, and then all those numbers added together gives us 64. By the way, when you convert general to standard for, whether it's circles, ellipses, hyperbolas, this number right here should always be positive at this point. If your number is negative at this point, something is probably wrong. I'm trying to think, is it even possible to ever have that negative? It is possible in a certain situation, but I'm not going to talk about it. But yes, it is possible, but the module shouldn't give you that situation. But I can't think of a situation where that can happen, but it shouldn't ever in this class. Okay, what's next? Divide everything by 64. Yep. And then we reduce. 4 goes into 64 how many times? 16. And 1 goes into 64 how many times? 64 times. And then of course, don't forget your 1. On your TGA, I said this before, if you give me an answer of a conic and you forgot to tell me equals 1 if it's a hyperbola or an ellipse, I will mark the entire thing wrong. Remember, an equation has an equal sign. An expression does not. So the equation in standard form of a hyperbola should always equal 1. If you want credit, you better have that equals 1. If you don't have the equals 1, I'm going to assume you actually don't know what you're doing, which is probably a false statement, right? But I'll just make the assumption just to give you no credit. What happened to the negative 1? So this one right here. I'm glad you asked. I am glad you asked. All right. So when we divide everything by 64, we just wrote that, right? 1 over 64 is already reduced. So when you write your final answer, do not put that 1 there because it is not simplified. You do not need the 1 because 1 times anything is itself. So there is no reason to put the 1 here unless you want me to mark it wrong for not being simplified. Do not put the 1 there. Does it explain your question? Okay, good. Very good. All right, everyone, let's try this one. Everyone try this one. Let me give you, I don't know, say 3.5, maybe 4 minutes. Ready, go. All right, when you are done, just give me a green check. Just wait for one more of you. Just curious, while we're waiting, has anyone in this class that's here right now tried to learn from the actual modules versus the live session? And if so, how did it go? Ooh, nice, Isabella. So Isabella, so you go through it. That's actually really good. Now, what's your opinion on learning it from the module before seeing it done in class? Yeah, yeah. So that's a true. That is true. Yeah. So sometimes I do the problems differently than how it's explained in the module. Um, Partly because I think I do it better, but just because I do it differently doesn't mean it is better. It's just how I do it, and I think it makes more sense. Um, But yeah, I think it is good. Like, if you have the time to go through and try to learn it before coming to class, I think that is a really good way because then when you hear it from me, everything seems to fall into place a lot easier. Remember, those modules, you don't have to learn from them. You can try, but they are still required. You need to go through them and work out the examples in both the learn and practice modules. So that part is required. If you want to learn from me, that's fine, but you need to work out all of the examples in both modules. I know I keep saying it, but some of you, when I actually click on your name in the grade book, and then I can actually go to the analysis, and it shows me down to the second of how much time you spend in each module, I am disappointed. Um, Not always, but I would say more times than not. I a little disappointed that some of you skip them all together. Some of you skip them all together. I'm like, I don't want to tell you. All right, what is the final answer to this? We're all done. What's the final answer? Oh, Brady. Brady, I would mark yours wrong. Brady, is yours in the form of a hyperbola for standard form? Yeah. So if you so when in your work, so let's show the answer. All right. So here's the answer. Who got this one correct? Brady, you're kind of correct, but I'd still mark it wrong. All right. So a lot of you got it right. Just scrolling up to read some of the answers. All right. So let's take a look. All right. Now, when you move the constant to the other side, and when you reordered, what should you write for your first two terms in this next step? What should you have written for the first two terms? Brady, did you forget equals one? Shame on you. I'm scrolling up to see your answer. Oh, you forgot equals one. That's bad. That's why we're all here. We're all here to learn. Yeah, so we should have the y stuff for if you're 64y squared, then you're plus 640y. Yeah, and then followed by the x stuff. You forgot the type. There you go. Yep. Yeah, so remember what I said. Um, we have y squared, x squared. One of them is negative, so it tells us it is a hyperbola. So because of that, when you list your terms in this step here, you have to put the stuff that is positive. Now y squared is positive, so the y stuff goes first. The x squared is negative, so that is what goes second. You're going to have negative 25x squared, and then your plus 350x. All right, then just to quickly run through it, we GCF, we pull out the 64. All of you should have pulled out the negative 25. And then we complete the square. 25 goes here, 49 goes here. What two numbers go here? Here and here. Plus 1600 and then minus 1225. Probably in that order too. Right, Brady? I'm just teasing. And then we factor it. Ooh, I made a mistake. I meant to correct it on this page. All right. So when you complete the square, make sure you take the sign with it. That is a negative 14, not a positive. So that means we should have a negative 7. It's a mistype on my part. No, nobody caught it. So that's important because when you go right from the trinomial to the factored form, looking over here, so this becomes x, whatever number this is, minus 7. So if you forgot to grab the negative, because this is a negative 14, if you forgot to grab the negative, like I did when I typed it over here, you might accidentally put x plus 7 right here. Rachel, did you forget? Did you put x plus 7 here, or did you actually put x minus 7? Oh, over here you're saying you forgot the negative. Gotcha. Oh, and then you put x plus 7. Yeah, so that's easy to do. Like, um, I just forgot to type it. I did actually type it out right over here correctly. But yeah, make sure you grab the sign. So that's a negative 14. So when you divide by 2 and square it, you're dividing negative 14 by 2, which is negative 7, and negative 7 squared is 49. And then once this factors, this is going to factor into x, whatever this number, x in this case, minus 7. So like what Rachel did, if we got that minus sign, you'll accidentally maybe grab the positive 7 here. So that's a common mistake people do. All right, then lastly, we divide everything by 1600. And then we simplify, right? 64 goes into 1600 25 times, 25 goes into 1600 64 times, and then, of course, it must equal 1. All right. Good? Good stuff? Pretty much just like ellipses, going from general to standard, with the exception of that minus sign. All right. Now the second half. Now we need to go from standard to general. So, what do we have to do first? Yeah, we have to find the LCD. We have to find the lowest common denominator. So, I'll give you all of you a 30 seconds or so. What is the LCD of 9 and 49? All right, looks like we all agree on 441. Yeah, sounds right. Um, so I recommend doing this grid, which I showed in class, that we want to do all of the, remember, it's prime factors. If I didn't say this before, it is prime factors. So the prime factors of 9 are 3 times 3. And the prime factors of 49 are 7 times 7. Now, if you notice, I have a 3 column, another 3 column, a 7 column, and a 7 column. Once you have all the columns and all the prime factors, you just drop all the columns. When you drop all the columns, you then multiply them all together, and that's how you get 441. That's how I recommend doing the LCD. It is, in my opinion, probably the easiest way to get the LCD. Yeah, the LCD, LCM, they're the same thing. The LCD is the lowest common denominator, whereas LCM is lowest common multiple. It's the same thing, but LCD is just being specific and saying it's the denominators. It's the same. Yeah, LCM, LCD. I kind of use them interchangeably when we talk about this. Yep, yep. All right. So once we have the LCD, what do we do? Multiply both sides by it. Yeah. So remember, this we're trying to clear the fraction. So multiply everything by 441. And so I show that work by doing this number times this number times this fraction, and then this number times this number. So I wrote it out. Some of you may skip writing it out, and that's fine, I guess. I think the more steps you show, the less chance you'll make a mistake. Some of you might go right from this right to the simplified, and that's okay, but you might make a mistake sometime. I don't know. So we get that, right? 9 goes into 441 49 times. 49 goes into 441 9 times. And then that, of course, just carries down. All right. What's next? Yeah, we want to FOIL it out. So we want to expand these binomials. And you can use the FOIL method. So you want to expand these. So what does this expand to? Yeah, y squared plus 16 y. Oops. I'm guessing you meant to put y instead of x. Habit, right? Habit. 16y plus 64. Yeah. Now, if you're someone that needs to actually write it twice and show the FOIL work, that's fine. Most of you in pre-calc should be able to go right from the binomial squared to the expanded form, because we all should know that 8 plus 8 is 16 and 8 times 8 is 64. So it's okay to go from here to here and vice versa, right? Should be able to go both directions. And same thing for here. This expands to this. 1 plus 1 is 2. 1 times 1 is 1. All right. What's next? Distributes. Yeah. So 49 times all of that stuff gives you that. All right. What did all of you get for the second or the second half of this side of the equal sign? What does this become? Negative 9x squared minus 18x minus 9. Anybody else want to agree with that? Yeah, that sounds right. Remember, we are distributing a negative 9. Don't make the mistake of doing 9 times everything. This is negative 9 times every single term. It does matter. Okay, what's next? Yeah, reorder. What goes first? Hmm. Looks like we're in disagreement. So remember, we are going to general form. So in general form, yeah, so Brady's correct. We want to have x squared first, then y squared, then your x term, then your y term, then your constant equals 0. That is general form. Well, Brady, if you throw enough darts at the dartboard, you'll eventually hit bullseye, right? Yeah, so general form. And of course, combine like terms. So when you reorder this stuff, we have to combine this constant with this constant to give you this. And then lastly, we're going to move this to the other side by subtracting it. So again, general form, if you want credit, it must be in this order. X squared, x, y constant equals 0. So just because it's negative doesn't mean you should not put it first. Now, I know why a lot of you wanted to say put the y stuff first, and that was because when we did this example over here, and we had to go from general to standard, then we had to reorder it so um, the positive squared variable was first, followed by the negative, because the form should end with the negative in the middle. But if you notice in this example, they started with the negative in front. Yeah, yeah. All right, let's go to this one. All right, what do we do first? We find the LCD. So let me give everyone about 45 seconds to do that. Everyone find your LCD. Ready, go. I had my mic muted the entire time. Thanks for telling me, guys. Jeez. I do that a lot, it seems. That's okay. It's all right. So what I was saying before is yes, the LCD is 100. The prime factors of 4, 2, and 2, prime factors of 100, 2 times 2 times 5 times 5. We line them up, we drop all the columns, and we multiply them to get 100. This is the way that I recommend to doing your LCD. It will ensure that you don't mess up. Yeah, remember prime factors. Prime factors. 100 is 10 times 10, but 10 is not a prime factor. So if you just factored 100 be 10 times 10, and then you had a 2 column, a 2 column, a 10 column, and a 10 column, then yes, that would be how you would get 400 instead of 100 as your LCD. All right. So yeah, we would multiply everything by 100. So I'm gonna jump ahead to the next question real quick, just to do the LCD for that one as well. So I would like everyone to do the LCD for this problem. I'll give you about 45 seconds again, and this time I will make sure my mic is unmuted before I start talking. Ready, go. All right, what did everyone get for your LCD? Looks like a lot of you or everyone is saying 324. What do you mean completely convert it? Yes, we are. I wanted to do the LCD of these two problems before going on, just to make sure that we're all on the same page on actually how to find the LCD. Because it's something that we learned in grade school, and however your teacher taught you in grade school is, I don't know. Maybe they didn't teach it. Um, my experiences, grade school math teachers aren't necessarily the best, even though there are some really good ones. So I am just speaking from experience. There are some really good grade school math teachers. And the reason why I'm saying this, I generalize this, is because in high school, teachers need to be what used to be called highly qualified. Now they call it appropriately qualified, that we take this a test to show that we are knowledgeable in the subject we teach. So your grade school teachers, sixth grade and down, aren't required to take a specific test to show knowledge because they teach every subject. Teachers that, as far as I know in Arizona, seventh grade and higher need to take a proficiency exam to teach that subject. Yeah, it's some, you don't need to know that. It's just something for qualifications of teachers in Arizona. So when you get a teacher that teaches you a subject in high school, for the most part, you should be relieved that this teacher supposedly knows their content because I took a proficiency exam. By the way, not to brag, but I'm going to. When I took my math proficiency exam, I scored max points in every single category except geometry. I scored 3 out of 4 instead of 4 out of 4, and it's because I never took geometry in high school. I never took it in high school. I never took it in college. So it was my weakest, I guess, skill. Um, so what I did, I taught geometry 1 year in my second year teaching. I taught geometry because I wanted to learn it. That's the only reason why I taught it. So I taught it 1 year, and then I was like, all right, I'm good. I know it. I don't want to teach it ever again. But I know my maths, guys. I know my maths. All right. So yeah. So let's go on this problem. So yeah, it is 324. All of you should have factored your prime factors of 36, your prime factors of 81. If you notice, we have we already had two three columns. So when you factored 81, two of those threes will go in that column we already created, and then we have to create two more three columns. Once you have all these columns created, we drop the two, we drop the two, we drop the three, we drop the three, we drop the three, we drop the three. It's a lot of threes. Multiply them all together, and that's how you get 324. So how did all of you do on the LCD? Some of you didn't respond. So I thought I'd just poll you guys and see. We got, looks like everyone got it right. Nice job. All right, so let's go ahead and finish this. Give you some time. By the way, it is 11:30 just about. So if you do have another class you need to go to, feel free to leave and to attend that. And if you want to watch the rest of this recording, you can at a later time. So let me give all of you, let's say 3 minutes to finish this problem. And then when you are done, give me a green check mark. Ready to go. If you're tabbed out, does it mean you're done? Or are you at a different class? Still working? Okay. All right, I'm going to go on. You all should be done by now, but it looks like someone is not. There you go. All right, what is final answer? What did you guys get? 9x squared. So 9x squared minus 4y squared minus 180x minus 48y. And then a few of you got plus 435. Somebody got plus 432. Two of you got plus 432. Let's take a look. I got plus 432 as well. What happened? Dang, Brady, you're 2 for 2. What's going on, Brady? What happened to everyone's right and Brady's always wrong? Oh, the tides have turned. Yeah. Any of you find out why you got 435 instead of 432? So where's the mistake at? What happened? For some odd reason, I wrote down 321 instead of 324. Yeah, yeah, that'll do it. Just you just wrote the wrong number down. Mm-hmm. That would do it. All right, so we do have one more, but I'll just show the work. That way we can call it a day. If you would like to work this out on your own, feel free to. It is this problem right here. Let me just show the work real quick for it, and you can work it out later. Multiply by 100, simplify the fractions, expand the binomials, distribute the 25 and the negative respectively to their binomials. Combine like terms so that 225 minus the 4, and also reorder. So for this problem, what term should go first? Yeah, the negative x squared should go first. So negative x squared, 25y squared, minus 4x, minus 150y, plus 221. And then lastly, move the 100 over by subtracting it. And then that is that answer. So we'll go ahead and stop here, guys. Fun-filled class, right? So that was day 3, which means you should all do the quiz after you've had a chance to go through the learn and practice modules to work out the examples in there, and then take the quiz. And then we will start day 1 of parabolas tomorrow, I believe. All right, guys, as always, thanks for coming, and I hope you learned something. I will see you all tomorrow.